Welcome to this explainer. Okay, today we are unpacking what might literally be the most profound paradigm shift the software engineering world has seen in decades. For years, right, we've thought of code as the ultimate output of a developer's day. But what if the code itself is no longer the bottleneck? What if the specification, that document we used to treat as just bureaucratic overhead, has actually become the source code? We are exploring the rise of spec-driven development, a world where the spec is the new compiler. Get ready, because this changes absolutely everything about how we build software. Let's kick things off with a number that completely sets the stakes here: 85%. According to recent data from Google's May 2026 white paper, 85% of developers are already regularly using AI coding agents. Let that sink in for a second. We are officially crossing the threshold. The era of purely hand-typing boilerplate code, it's rapidly ending. The question isn't whether AI is going to write your code anymore, it's whether what you hand to the AI is actually good enough for it to build from. Here is our blueprint for today's explainer. 1. The end of typing. 2. Vibe coding versus engineering. 3. The 3 levels of specs. 4. How your job changes. And 5. The verification era. All right, jumping right into section 1, the end of typing, the factory model. So this whole shift is brilliantly captured in that May 2026 white paper from Google researchers Adi Osmani, Shubham Subbu, and Socrates Kartakis. They describe this sort of factory model of software creation. In this model, the developer's primary output isn't the code itself, but the system that produces the code. 41% of all new code is now generated by AI. Because of this massive surge, our fundamental bottlenecks have completely flipped. We aren't waiting on human hands to type out functions and loops anymore. Instead, we're waiting on human minds to define the boundaries. AI can compress implementation from weeks down to hours, for sure, but requirements, architecture, and verification, those remain stubbornly human-paced. Think about it historically. Every major leap in programming has basically been a renegotiation of what we do by hand and what the machine just figures out for us. Assembly language let us stop writing raw opcodes. High-level languages like C and Java, they let us stop manually allocating registers and tracking garbage collection. Every single leap handed a mechanical layer over to a compiler while keeping the actual intent with the human. Well, today, the AI agent is our new compiler, and the specification, that's our new high-level language. Which brings us to a formal definition. Spec-Driven development, or SDD, is the practice of defining behavior, constraints, and edge cases before building, in a structured form that acts as the instruction set for an AI collaborator. Specs used to be these static documents that nobody read, right? They went obsolete the literal day the software shipped. But under SDD, the spec is the absolute living source of truth for both humans and AI. It is literally the language of the compiler. Moving along to section 2, Vibe versus engineering, the AI usage spectrum. To really grasp this new era, we have to look at the quality of our AI collaboration. On one end of the spectrum, we have what's called vibe coding. This is when you just throw casual prompts at an LLM, generate some disposable code, and maybe build a throwaway weekend project without rigorously reviewing what it actually wrote. It's fun, but it's super fragile. On the completely opposite end, we have agentic engineering. This is how you build production systems at scale. It requires formal specs, continuous integration gates, and constant, rigorous human verification. The key differentiator here isn't whether you use AI, it's how much structure and human judgment surrounds the AI's output. And the reason we absolutely need that engineering structure comes down to the 80% problem. AI agents are fantastic at rapidly generating about 80% of a feature, the boilerplate, the standard logic. But that remaining 20%, the weird edge cases, the strict error handling, the subtle correctness, that demands deep contextual human knowledge that these models just don't possess. If you don't explicitly specify that 20%, the AI is just going to guess. And trust me, you do not want to discover its bad guesses when you're live in production. All right, section 3, the 3 levels of specs, climbing the framework. So, how do we actually lock down that final tricky 20%? By climbing a 3-level framework. Level 1 is all about clarity. At this foundational stage, specs are tools to remove ambiguity before the build even begins. You aren't just writing a vague wish, like validate permissions. You're answering exactly why, what, and what not. Teams are achieving this using structured formats like EARS notation, which stands for Easy Approach to Requirement Syntax. So instead of saying handle errors gracefully, you write, when a user requests checkout, the system shall lock the document.
It's all about writing highly testable criteria that an agent can actually act on deterministically. Stepping up to level 2, we see how this really builds. Here, specs become contracts. They stop being mere descriptions and become machine-enforced binding rules. You pin down explicit shapes, closed status sets, and exact database schemas. This is a practice known as context engineering. You aren't just prompting the AI anymore. You're giving it strict architectural constraints so that it cannot quietly deviate from the design or just invent arbitrary data structures as it jumps from file to file. The spec forms a totally rigid boundary the AI operates within. And finally, we hit level 3, invariance. At this advanced level, the spec actually becomes the primary interface to the AI. You define explicit business rules and strict failure modes. These then compile into automated property-based tests that don't just check one happy path, but generate hundreds of arbitrary scenarios to prove correctness. Crucially, at this level, no agent's code gets merged until it passes n consecutive green runs in your continuous integration pipeline. The spec states what must always be true, and the pipeline ruthlessly enforces it. Now, if you're sitting there thinking this sounds purely theoretical, let's talk about Skills Home. It's a live skills verification platform currently in beta, handling highly sensitive hiring data. And get this, it was built entirely using spec-driven development. Every single feature began as a formal spec, was implemented by an AI agent, and had to pass a grueling gauntlet of 476 total tests to prove exact correctness before it was merged. No human hands wrote the implementation, but humans engineered every single ounce of the intent. It's absolute proof that this workflow operates flawlessly in real-world production today. Which brings us to Section 4, How Your Job Changes. Roles Reimagined. Seriously, with the machine writing the implementation, what do you actually do all day? Well, traditional roles are fundamentally transforming. Product managers used to write these long narrative product requirements documents that engineers basically had to interpret. Now, they write testable acceptance criteria that double as evaluation code for the agent. QA engineers used to test software after the fact, hunting for bugs in the finished code. Now, they co-author the properties within the spec before any code is even generated. Architects used to draw diagrams for human teams. Now they're writing machine-checkable constraints that the AI literally cannot violate. Everyone is collaborating on the exact same artifact, the spec. What we're seeing here is a core structural shift across all tech teams. Work is hollowing out the middle implementation layer. The day-to-day grind of typing out logic, it's gone. Instead, human effort is being pushed to the edges, upstream toward defining intent and downstream toward verification and auditing. In fact, this shift is so huge that completely new AI-native roles have emerged across enterprises. We're talking about roles like the agent engineer, who designs and deploys these autonomous agents, the AI orchestrator, who acts as the architect for complex multi-agent workflows, the context engineer, who meticulously designs exactly what information the AI sees, and the AI output reviewer, who is essentially an auditor validating that the agent's actions strictly match the baseline of the spec. These aren't futuristic concepts. They're literally some of the fastest growing job titles globally in 2026. And that leads us into our final section, Section 5, the verification era, the new industry craft. Okay, as human developers step away from the keyboard, we have to be incredibly careful about the trap of plausible-looking output. Because AI is so articulate, it will generate code that looks absolutely brilliant and works flawlessly in a quick demo. But here's the thing. A working demo just proves an agent can succeed exactly once. It is absolutely not the same thing as correct, verified output that passes consecutive CI runs and gracefully handles the roughest edge cases. Getting from plausible to verified requires intense, human-led engineering rigor. I really want to highlight this quote from the Google May 2026 white paper because it just hits the nail on the head regarding everything we've talked about today. Generation is solved. Verification, judgment, and direction are the new craft. Your value as a professional is no longer measured by how fast you can type out a function. It's measured by your ability to judge ambiguous trade-offs, direct autonomous systems clearly, and relentlessly verify their outcomes. Which leaves us with a pretty big, provocative question for you to take back to your own projects. If you hand an AI agent the keys to write your implementation tomorrow, how exactly is your team verifying the original intent? Are you relying on casual vibes and a quick code review? Or have you built a machine-checkable spec that demands correctness? The era of the spec as the compiler is officially here. The only question is how quickly you're going to adapt to writing the intent and letting the machine do the typing. Thank you so much for joining me for this explainer, and keep building brilliantly.